Let's move on to another problem. So now you have an array of size n, okay, and I'll ask you a very simple question to start with. So let's say the elements are 1, 5, 2, 4 and 3, okay. What you have to do is you have to print the sum of every k-sized subarray. Print the sum of every k-sized subarray. So let's say the value of k is given to be 3. Okay, at this point of time, what is a subarray and how is a subarray different from subsequence? Can somebody tell me what is difference between subarray and subsequence? Subarray means contiguous, but subsequence needs not be contiguous. So like 2, 4, 3 is a subarray because these are contiguous. But is 5, 2, 3 a subarray? No, because 4 was missing. So subsequence can be non-contiguous. Subsequence can be 1, 2, 1, 2, 3, anything. But subarray has to be contiguous. So you will be given integer k, and for every subarray of size 3, you will have to print the sum of that. Okay. Cool. So can you first tell me how many subarrays are there in this that are having size equals to 3? Okay, there are 3 of those. So I can say that maybe this is the first one, and then this is the second one, and then this is the third one. Okay, so there are 3 subarrays here whose size is 3. So the sum of first one is 8, the sum of second one is 5 to 7 plus 4 11, and the sum of third one is 2 3 5 plus 4 9. So I have to print 8, 11 and 9. So how can I do it, guys? One way is to consider all these subarrays one by one and figure out their sums. But if you do that, think of it in this way. How many elements are there in any subarray? In any subarray, number of elements is k. So if you compute the sum of this entire thing one by one, how much time will be taken? Order k time. So order k time will be spent at every subarray. And how many subarrays will be there? Can you tell me number of subarrays if the size of array is n and I am considering k-sized subarray? It will be n minus k plus 1. You can do that. You can just check that out. There will be n minus k plus 1 subarrays. Okay, and how can I say that? Because there will be a subarray that starts from index 0. There will be a subarray that starts from index 1. There will be a subarray that starts from index 2. What will be the last index from which a subarray of size k starts? That index for sure will be n minus k plus 1. Okay, why this will be n minus k plus 1? Sorry, this will be n minus k, because if this is n minus k, then only if let's say there are k more elements, then you can add, excluding this, k minus 1, and then the last index will be n minus 1. So there cannot be a starting index which is after n minus k. So the last subarray of size k which will be there, it will have its index as n minus k. So how many subarrays did you get? From index 0 to index n minus k, how many terms are there? N minus k plus 1. So you are going to get n minus k plus 1 subarrays. So if there are n minus k plus 1 subarrays, and for each subarray you are doing this much work, your time complexity will be this much. And if let's say your k is n by 2, then this will be n by 2 and this will be n by 2, and your time complexity would be order n square. So this is not, brute force approach is order n square, and this is not very efficient one. So can I do better than this? Think of it in this way. If you take any array, let's say 1, 5, 7, 0, minus 1, 2, 3, and let's say you are considering every 4-sized subarray. So if let's say this was your first subarray and it had a sum s, okay. Now the next subarray will start from here and end here. Can I say that the difference between first window, let me call it window, which starts from a point, ends at a point, starts from a point, ends at a point, the difference is just of 2 elements, right? So whenever this window progresses by 1 unit, one particular element is kicked out and another element is welcomed. Can I say that? So the sum computation will be very easy if you think of it in this manner. Let's say the sum of this was equal to S, okay? And now if let's say you are sliding this window by 1 unit, so let's say if this index was I, so you let go of this element, and if you welcome a new element at index J, then you just add this. So the sum of next window can be figured out in just order one time. Again you slide it, so you get rid of 5 and you add 2. Again you slide it, you get rid of 7 and add 3. So what will be the time complexity of this approach? This will be how much? Simply order of n. Why? Because in order k time you will find the sum of first window, and then for every other window you just need order one time more. And how many more windows will be there? There will just be more, almost n minus k more windows. So order k time here, and then order n minus k slides where you are doing just order 1 computation. So it is just order n approach. Okay.